with the stream working? Yes. Okay. Well, hello everybody. Thanks for having us again after last year. My name is Ramiro. I'm an architect at Atlassian right now. I worked on HipChat data center on the enterprise offering. Before that, I used to work for a startup with Pablo where we were working on solutions for application lifecycle management back then when multi-cloud was all the rage before containers happened. And before that, I used to work for Microsoft on Windows Azure on some of the cloud services they were offering way back then. And Pablo here, he's a tech lead on Docker's SaaS offering, so Docker Hub, Docker Cloud, all of those things. Again, thanks for having us. And today we're going to be talking a bit about Docker, about like how you take your applications from traditional physical servers, VMs, all the way to Docker. And then we'll talk a little bit more about best practices around deploying applications, keeping them online, all that fun stuff. Just mandatory slide. These are our opinions. We might cover a couple of controversial topics that represent our views of containers and applications. They might not necessarily represent Atlassian's or Docker's views yet. So yep, we're going to cover through this. Why containers? What are they good for? What are they not good for? Then we'll get a little bit on how to get your containers online. And then finally, we'll talk about an open source project I took that Pablo and I have been working on for a bit.
Okay. So why containers? In this part of the presentation, we are going to talk about what is the goal of running our applications in containers. I think there is a kind of misunderstanding about what is the meaning of Docker. We will analyze this problem in detail. And then once we have our application in a container, we will see how to deploy this application in production. So why Docker? Let's make a small journey 10 years ago where we had our legacy applications running in manual infrastructure. And what I mean by this is that our applications are running in physical servers. There is a problem with this configuration, basically, is that everything is manual. It's very difficult to automate the creation of an environment or to scale our application or to recover from a failure. And the main problem, well, there are a lot of issues with this configuration, but the main problem is that it's not replicable. It's very difficult to create environments, and this is an issue to create testing environments on demand, staging environments, and so on. So this was 10 years ago, and then we have the first revolution, the cloud application era. And the main feature with the cloud, both private and public, is the possibility to create infrastructure on demand. And we can create the scripts to create our physical our virtual servers, and then we can start to do some fancy tools like continuous integration. Every time we have a commit, we are going to be able to create a virtual machine, deploy our code, test, do some end-to-end testing, and so on. So the main feature that we have with the cloud is the feature of automation. We can automate the creation of environments, and this is very cool. And also we have other services on the cloud for highly available services like load balancers, auto-scalability groups, DNS as a service, which is an add-on to the possibility of creating infrastructure on demand. So all this is very cool, but there is a new problem with the cloud, and it's the portability between the local environment, the code that the developer is working on, and the different environments like continuous integration, staging, and production. So in order to solve this problem is why the containers appear. A container basically is a runtime which is portable. It doesn't require it's portable between different infrastructure and different operating system and distribution. It doesn't matter if you are running in a Mac in a local environment and then you go to staging and you are running in Ubuntu, the container is going to run the same, and this is very important to solve the typical problem of it works in my machine and so on. So this is the main feature of Docker, is the possibility to run the same container independently from the infrastructure and the operating system. This is very powerful. And other features that comes with Docker is the possibility to distribute the software very easily. As you know, you have the Docker registry. You can push and pull an image from any machine to any other machine. And thanks to the portability, you are sure that your container is going to run the same. This is very powerful too. And last thing is about lightweight. At the end, the container is a virtualization technology, but it's very lightweight. So you are able to run several containers, hundreds, even thousands of containers in a single machine. And this is very powerful, for example, if you are working with microservices and you need to deploy a complex environment like, I don't know, 50, 100 services in a local machine. Thanks to the lightweight of Docker, you are able to deploy all these services in your laptop. So with these features, I think that there is well-known best practices for continuous integration, like image scanning for security vulnerabilities, or image signing to be sure who is the creator of a given Docker image, or different tagging schemas to be sure about which container is running which commit. So there is a mapping between the container that is running in production and the different commits in Git. We are not going to talk about the continuous integration thing in this talk. If I remember well, we talked about this in the last talk. So we assume that all the continuous integration is taking advantage of Docker, all the best practices, and then at the end we have a container which is validated and is ready to run in production. And in this talk, we are going to focus on this problem. Okay, we have our container, it's ready to run in production, but how do we do it? And for that, Ramiro is going to...
I'll take it from here. So yeah, at this point, you have your containers, as Pablo said. And this is a problem the industry is facing. As containers gain adoption, there's a myriad of tools on how to get this online. Now, before we get into tools and whys, I would like to cover what do we mean by getting our containers online. Because one thing is you have your application on your dev station, maybe even a test environment, Docker Compose up, it's all up and running. You're very happy, you push to master, and then you want it to go to your customers. For us, these are the four main pillars of what we mean to have an application running. First one is that it's replicable. You're gonna have your application running for a very long time. You wanna be able to have different environments, test, stage, prod, canaries, all of these things, and you want to make sure they're all the same. Because you want to be able to, when you have issues, if you are running into anything in production, performance issues, bugs, one-off things, you want to be able to replicate that somewhere else, troubleshoot it, fix it, and then push it back. You don't want to have to log into server, get data from there, try to figure things out, restart processes. That is a thing of the past. That is something that we've done for a very long time, but over the years, we've all kind of come to an agreement that it's not really in our best interest. Second one is you want things to be standard. This is something that matters more for teams or larger companies, which is that you want as many of your services and applications to behave the same way. Ideally, you use the same tooling, the same platform, the same tech stacks if you can, but at least you want to make sure that services behave the same way. Why? Because when you want to develop it, when you want to fix issues, troubleshoot, if you're using the same metrics, the same dashboards, the same logging systems, everything's going to be easier, especially if you're growing your teams and you're hiring. Having something very standard so you don't have to retrain everybody every time they work on a new service becomes really important. And particularly in my experience, when you're having growing pains, as you ramp up your services, you will go through this phase where services are going to be kind of online, but start failing a little bit more than you want. And that is where having a standard platform for everything helps everybody. Third, and for me, kind of one of the more important ones, it's available. Services only matter if they keep running. Your customers are not really going to care of VMs, containers, lambdas, whatever you have, if they're not available. Whether your consumer is your end user, another service, a watchdog, a metrics agent, if it's not online, it's going to be a lot more trouble. You want your services to be able to run like water. And finally, you want your application to be traceable. What we mean by this is you want to be able to know at any given time what's going on with it. Dashboards, CPU metrics, memory, network, application level things like, I don't know, how long it's taking for a transaction to be processed, how many messages are you dropping. All of those things are very important, again, because you want to know how you're operating. It's going to be very hard for you to reach 3, 4, 5 nines unless you know these things all the time, unless you know when your services are getting into a degraded state and when you want to take whether it's a corrective action or start focusing on other areas. It's really up to you, but knowing the health of your service at all time really helps you get it to the next level. So going a little back, you have your container, it's ready to go, and kind of basing on like, we want all of these things. There might be more, maybe you don't care about some of this, that's okay, but you want your container up and running. So what do we do? Well, the industry seems very focused on this one tool, Kubernetes. Tool built by Google. It was Borg before. It's this massive, highly scalable, apparently scales forever tool that's going to solve all of our problems with containers. And this seems to be like where everybody's going. Every company I've talked to, Atlas internally, we're all like, oh, I have a container. I want to get it up and running. Well, Kubernetes. Just set up a cluster and you deploy and everything will just work magically. And yeah, when you're testing, maybe it works. Once you hit production, especially with legacy applications, it's rarely the case. And this is because, this is kind of my thought on this, Kubernetes is not really a tool for deploying containers. It's really a whole new developer paradigm on how you build applications. Kubernetes is a really good tool, but its main strength is optimizing infrastructure utilization, making it super scalable, but it has a cost. It's very hard for you to take any application, any container, and just put it in Kubernetes. Service discovery, load balancing, placement constraints, all of these things matter on how you're building applications, how you consume environment variables, how you consume configuration files. At Atlassian, we went through this internal effort to port some of our applications from traditional Python-based apps, Django, that kind of thing, into Kubernetes because we thought, hey, it's a Python app, put it in a container and ship it. And as soon as we started pushing to production, we started running into issues. Kubernetes is a great tool, but it's not for everybody. There is all these layers of abstraction that you have to worry about, and it's not really for everybody. For us, one of the metaphors we use is that Kubernetes is like a hotel, something where it's highly scalable, highly dynamic. People check in, people check out, and it's great. But to run a hotel, you need to have 24/7 staff. You need to have a much bigger building. You have to invest more on it up front. This is the kind of things you have to think about when you're moving to Kubernetes. And for us, and it's kind of what we're talking about here, is that Kubernetes is not the only way to deploy containers. It is becoming the most famous one for many reasons. It is a cool technology. It is a whole new like jump in a lot of things. It has big backers, Google, main one, and others. But it's really not the only way. Like, we do believe that for most use cases, we can use the power of cloud-native features to manage and deploy our applications. Because at the end of the day, the cloud provider itself, AWS, Azure, OpenStack, even vSphere, are very robust orchestrators in their own right. And they are well fit for container-based applications. This is something that it's a bit of a iffy point in the industry right now, but we believe that we can take most of what we know about cloud applications and use them to power container-based applications. You don't have to throw everything you know and jump at this new paradigm for every single thing you do. And here is where we come with the what we call cloud containerized applications, which is you have a container, you have an application, and you're going to use cloud features to ship it. Why? Why using, so what's this model? For us, the model is kind of, and simplifying it to, you have a VM, you're going to deploy your VM with your containers on it. Why? Because VMs are the prime deployment unit for cloud. It integrates really well and it's secure. Clouds are evolving. We have things like Fargate, like AKS, that is moving into making containers or making Kubernetes a first-class citizen, but it's not quite there. If you've ever looked into the security of this, running containers on a multi-tenant environment is really a no-go. It's not a secure thing. VMs are far better understood. They are a better security perimeter. Also, there's a lot of advancement into making them more performant, fair use, all of these things. And then you have your VM, and you have your container. And being able to run containers on a VM instead of just on a pod or something else, it really gives you the best of all worlds, or at least that's what I think. It gives you the four things. It's replicable, it's a standard, it's available, it's traceable, but you also gain most of the things you would gain with Kubernetes. Dynamic placement, scaling up and down, easy to just kill the environment and launch it again, all those sort of things without having to really go all the way there. And going back a little bit to what we mean by this is the replicable, standard, available, and traceable applications. So now we're going to build the detail into this. What do we mean by replicable? We mean by the test, staging, production, all of it is the same. You have different scale. You might have different variables, of course, passwords, users, number of nodes, whether you're going to report a failure or not, all of these things. But containers gives you this. It's a great fit for this. That's kind of the problem that containers are trying to solve. Is I have dependencies, I have code, I have runtime, but I'll make sure that it's as close as possible among all the different environments. And then containers have a lot of other features, tags, registries, to make sure that you have the same container everywhere. You can have your container, create on CI, push to a private registry. From there, you can push it to your production registry. You can push it to a staging one, but maybe it's only available on your VPC. You can public if you want, if you're building public images. You can really move containers around, and you can sign them, you can scan them, you can make sure that you are getting the right thing. There's a lot of technology there that we can use for this. And the other part of this is that once you deploy your application, it never changes. You can build an AMI, in the case of AWS or any other cloud provider, with your container there, and the AMI itself, just like the container, will never change. You can go into a runtime one, modify something, maybe if you have SSH access, but the VM itself will never change. And again, VMs are really great for this. They integrate very well with all the security models that cloud services have, load balancers, log collectors, all of these things. And now, especially since LinuxKit was announced, there is a big push of making VMs smaller and smaller. The boundaries of containers and VMs are kind of merging a little bit if you think about all of this. So you're going to get much smaller VMs, which are faster to deploy, which are easier to deal with, and which have a smaller security footprint, something that's also important. If you're running containers or VMs, you don't need all of the different services that your VMs might offer. If you don't need, I don't know, if you're not ever going to SSH, there's no reason to be having that service running. It's one less thing you have to worry about from a security perspective, and things like this. And then finally, when it comes to making it replicable, CloudFormation, Azure deployment plans, this kind of things also make it relatively simple to have replicable environments. You can have production, you have your template, and then you can spin up another branch of it just to replicate something. Maybe you want to do some perf testing or pen testing or anything really you want, even local devs. You can just spin up environments with relatively ease. And that's kind of where second thing, and again, this matters more for teams and larger companies, which is having things become a standard. If you go through this model, containers, VM, you kind of start on this model where your software is just boxes. Similar to just containers or even Kubernetes, but you can also standardize at the stack level. You can have standard naming schemes for discovery, for how you deploy with CloudFormation. You can use something like CloudWatch for log management. You can use ECS as standard registry. As you move through this model, it can be a chance for you to start building your applications in the same way. Your stacks might be different. You might have PHP, Ruby. I think this is mostly a Ruby shop. You might have some Java, Scala, Elixir, whatever you have. But having all these like cloud services help you package your solutions do help in making things look a little bit the same. Once you have your logs piping through CloudWatch, it's easier to build dashboards in Grafana, to push it to like an Elasticsearch somewhere, to do more like deep analysis of your logs, all of these things. And something that I found that's very valuable, that is normally overlooked about standardizing, is that as your teams go through this journey, every other team benefits from improving operational excellence. You can start building playbooks of how do you deploy a new service? Well, take this template, change the AMI, and go. How do you troubleshoot when you're having some connectivity issues, when you're using, I don't know, some services? How do you deal with a SQS backlog? How do you deal with peaks in usage? All of these things, every other team can benefit from learnings as they go. This is something that Atlassian we went through the last 2-3 years. We built an internal platform for shipping services. There's a lot of pushback initially from developers because all of our teams were like, no, I know how to do that. I can do that better. I want my custom thing. Some of us were using like manual deployments. Others were using containers. And at the end, being able to move all of our services to this common platform has helped us increase our availability, like going from 2 nines, 3 nines to 4 nines for different services, because then you have this book of like, okay, new team, new services here, follow these 10 steps. Put your name here, your email here, your pay your duties here, your dashboards, your metrics, all of this. Everybody gains from this. And right now we're moving to a container world, but it doesn't really matter. Like you could have this on VMs, you could have this on function as a service. It's more about using these technologies as a way to push a certain level of uniformity in your applications that is super valuable in my experience. And next, again, the most important thing, availability. Your application has to run. The application has to be there. It has to not crash as much as you can and to give you access to it. And this is where I do feel like right now, native cloud features have an edge over Kubernetes, because something as simple, quote unquote simple, as having elastic load balancers with auto-scaling groups really make dealing with peaks, especially if they're kind of semi-predictable, much easier. In Kubernetes, you have to prepare your Kubernetes cluster, then add a bunch of plugins to make sure they react to the scalability, but they're going to react to scalability as a cluster, not as an application, which might work for you, but it has a different set of constraints. Also, you have other ways of doing a scale, of dealing with failover. A node will die. Like VMs are disposable. Amazon itself, it will shut down your VMs from time to time if they have a new host, if there's some new patches that need to be applied, whatever. So using things like load balancers, ASGs, and similar are really great. And the other aspect of availability is upgrading. And this is also something that is sometimes overlooked when you're designing your deployment in your application is your customers don't care how many times you deploy per day. If it's 1, if it's 2, if it's 10. They want things to be available. And that's where your upgrade and deployment practices also have to evolve. You can no longer just shut down your application, upgrade it, start it again, and okay, well, you had a few seconds and maintenance, whatever. It's no longer acceptable. Like all of our customers are used now through the internet of like, oh, I just refresh on it, it should work. Oh, bad request, it should just auto-connect. On HipChat, if you ever use HipChat, we went through a very insane, bad journey and not doing this well. We learned a lot from it, and Stuart is benefiting from it, but this is where something like CloudFormation really helps. Native rolling upgrades, rolling backs, and even like blue-green deployments if you're using something like Route 53, which is AWS's DNS. This is where, again, having your VM, your container, allows you to benefit from all of these features. If you go to Kubernetes, you do have to change your entire strategy. How you do upgrade, how you do containers, it's a little bit harder. So again, I'm not saying that Kubernetes is not good for these things. It is good for these things if your application is built a certain way. The point I'm trying to make is not the only way. Especially if you want to get to Kubernetes, if you're not there yet, if you're just starting with containers, taking this a step, even if it's not your final step, is something I would advise to try. Evolve your practices one step at a time. Don't go like all the way to Kubernetes just because that's what the industry is saying is like the great thing. And then traceability. Again, it's something where Amazon, in particular, Azure as well, but not as much, has great features. Cloud Logs is some CloudWatch, something that we should all be using more of. You get log management that scales reasonably well. And Docker has a really good driver for this. Like you have your container, you can just configure, when you start your container, you just forward the output to CloudWatch. You don't have to do anything. From there, you could have SQS events for like processing, for raising alarms on errors, on failures, on certain metrics, or just forward to other things, to Splunk. We use Splunk internally, but it's really all about your scale. And another really good thing that I found useful about having your containers on VMs, even if they're smaller VMs, is that it's far easier to understand CPU, memory, and similar metrics on Kubernetes on a large scale cluster. You have the noisy neighbor problem is a lot harder to figure out. Amazon, all these cloud providers have spent a lot of time solving these issues at the VM level. So you can have a certainty you will get fair use. Once you go to Kubernetes, especially if you go to pods with oversubscribed nodes, it's really hard to know when your application is not performing well, if it's because of your application or because the environment is noisy or something happened. And here is what I've seen some very anti-patterns to kind of emerge, where you have your applications in Kubernetes and you start putting so many placement constraints on them to ensure certain availability that you end up with one pod per VM and you don't share anything else. And at that point, it's like, why are you using such a dynamic orchestrator if you want to tell the orchestrator, put this application on that VM and this application on that VM? At that point, you don't really need that layer of abstraction. And here I'm talking about AWS because that's what we use internally, is what I'm more familiar with. But this applies to really any public cloud provider. Like something's really good about the time we're alive is that all this competition has forced all the providers to catch up. Every time AWS launches a service, either GCE or Azure or even like DigitalOcean will catch up. So a lot of these practices are not just for AWS. Even OpenStack is kind of falling behind a little bit, but even OpenStack has a lot of these things. And then others, Cloud Foundry, all of these other providers as well have some of this. The idea here is that you don't have to just go to Kubernetes. There are other practices. You can evolve your practices through battle-tested cloud features that work as well, and sometimes even better, than what other more dynamic orchestrators can offer. And yeah, there is the VMs are big and slow. That is true. They are. They can be very large. You can have a VM, if you're not careful, with 20, 30 gigs, that will take 10 minutes to deploy. But there's a lot of research into this. First, there's a lot of guidelines around how to making VMs smaller just by cleaning them up, reducing file sizes to being more specific with what you need. But there's also things like LinuxKit. I'm really excited about how LinuxKit is moving a little bit the deployment study forward of containers and VMs kind of merging, having much smaller VMs that are faster and easier to deal with. But there's also a lot of research. This paper called "My VM is Lighter and Safer Than Your Container" is making the rounds. It's published this year. Yep. And it talks a lot about how having smaller VMs is good just because they kind of can be as fast and as densely packed on a host as containers. But also it gets deep into the security issue. And this is true. Containers are it's relatively easy to elevate privileges across containers or to access the host. Containers were never meant to be a security boundary the way that VMs can be. It's meant to be a process running on an OS. So there is a challenge with containers, especially in Kubernetes, on how do you share secrets? How do you make sure that certain traffic only flows through certain containers? And this is another area where, in my experience, this kind of environments have a little bit of an edge right now. This might change next year. Who knows? But right now, that is where I think we are. So, and to be honest, nothing of this is revolutionary. We've been doing this for a while. Every team I've worked at, I'm sure you've been doing the same thing, have used a ton of different tools to accomplish something similar to this. There's CloudFormation, there's Terraform, Ansible, Chef, Puppet, Bash scripts, people manually SSHing and running through some safe commands. There's nothing new here, just a VM running container. But it's a problem that every single team has. At our last company, Pablo and I, and some people in the back too, we're trying to solve this problem. We built a company trying to solve this, and we spent a lot of time thinking of every single team needs to do this. Every single team, somebody joins and somebody starts writing all these templates and is spending time on things that are typically not core to your business. Pablo and I spent a lot of time on that place. That's the brewery in Mountain View, talking about this and how it makes better and trying to invent all these different things. Because at the end of the day, every time you spend thinking of your deployments, worry about how you're going to do upgrades, is time spent away from your core mission. Stuart's core mission is not to deploy containers. Doesn't matter. That's just a means to your end. So we're thinking, okay, what can we do? And after kind of a lot of coming and going, Pablo and I kind of came with hey, if this model works for us, maybe it can work for some other people. And we started an open source project called I2Kit. Pablo will get into more detail on that.
Yeah. So I2Kit is an open source tool for deployment. It started as a Docker hackathon 6 months ago with the LinuxKit community. And now Ramiro and me are working on it to take it to the next level. And so basically, when we started I2Kit, we collected a set of requirements, and we are very focused on solving these problems with I2Kit. So our requirements are: we want to benefit directly from the cloud provider features. For example, if you are using Kubernetes, yes, you can take advantage of load balancers, but you need to hack a little bit Kubernetes to use this technology. We want I2Kit to offer these features directly. The next requirement is that one of the things that I like a lot about Kubernetes or Docker Swarm is the user interfaces, the YAML files to define the application behavior. I really like to have a Docker Compose and deploy a local environment with a single command. I think people is getting familiar to this syntax, and it's something that we want to keep in this tool. The next thing is that we don't want to manage a cluster. Something that Ramiro didn't talk about in the previous slides is the cost of maintaining a Kubernetes cluster. It's not only the learning curve to learn how to do things in Kubernetes and all the different development practices about Kubernetes. It's also that you need to maintain a cluster, and maybe something is wrong with your cluster, you need to fix it. It's a pain in the ass. One of the requirements we want to have in I2K is that there is no cluster at all. Everything is running in the cloud, and I think there are enough tools in the cloud like security groups and load balancers to have high availability without having an I2K cluster taking care of this. And last thing is the problem of the noisy neighborhood in Kubernetes or other container cluster tools. We don't want to have this problem in I2K. We trust the security boundary of the VM. As Ramiro said, the VM integrates very well with the rest of the cloud features and give us the security that no other VM is gonna do anything wrong with the rest of the containers. So the proposal is I2K yeah. So basically, let's go again about the best practices in the cloud. We want the replicability of containers. So basically, in I2K, the core idea of the I2K is that for every container, we are going to create a Linux distribution using LinuxKit, which is specialized to run only this single container. This is good for security because the VM is specialized only for this container, and the attacking vector is reduced. And also, as we said before, it integrates well with the rest of the cloud features. Also, as I said before, I2K is going to provide a manifest file, a YAML file very similar than Kubernetes or Docker Compose. So it's going to give us the standard about how to deploy containers in production. Then we will have availability because we will be using load balancers, security groups, and other cloud features to provide the same features that Kubernetes have. And also we can redirect all the containers output, for example, to CloudWatch logs to have monitoring. And this is just an example of the manifest in I2K. Basically, it's a simplification of a Kubernetes manifest. You define the name of the service, the different replicas that are going to be running, the container image, and you can also define ports. The syntax for ports is a little bit extended to support the different protocols in the load balancer, and also you can define different variables and all that. So the abstraction that we are going to provide is that for this manifest, we will create the infrastructure in Amazon. Right now, the I2K prototype is integrated with Amazon, although other providers can be supported. But the idea is that for each service, we will create an auto-scalability group to ensure that we have the number of replicas always running. If anything wrong happens with the VM, the auto-scalability group will create a new VM. And for each of the containers, we have the LinuxKit VM running this container. To proxy the traffic for the different VMs, we have the load balancer, the Amazon Elastic Load Balancer. And for service discovery, we will create a DNS entry in Route 53 resolving web server to the endpoint of the load balancer. So we have service discovery by default. If you think about this schema, it's very similar than the functionality that Kubernetes provides. In Kubernetes, this is a manifest for a deployment manifest. And the abstraction is very similar. Instead of using auto-scalability groups, Kubernetes has the replica set. Instead of using a VM, Kubernetes is using a pod to run your containers, which is an abstraction of a VM. And instead of using a load balancer, Kubernetes has the kube proxy to forward traffic between the different pods. And also the service discovery works very similar. Kubernetes will create a DNS entry for resolving this name to the proxy that is forwarding the traffic to the different pods. The nice thing about the I2Kit tool is that all this abstraction is provided without the need to keep this complex setup in Kubernetes. In Kubernetes, you need to handle different masters. You need to install a etcd database to have highly availability. You need to run different components in the different worker nodes. And all this is a complex setup, which is not only difficult to deploy, it's also difficult to maintain. And you can always have the problem that something is wrong here, and it's very difficult to troubleshoot. With this approach, you don't have to manage the cluster, and also if something is wrong in Amazon, you can always open a ticket and ask for support from Amazon. So this is the proposal that we have in I2Kit. This is the link to the source repo. If you like the idea and the best practices that we want to propose with this tool, please check it out and give feedback. It's an open source tool, so feel free to open issues or open pull requests, or just give us some feedback. And that's all. Time for a question.
Yep. Thanks very much.
So I've been thinking. We have this thing in Stuart. We were thinking about this, and I want to know your opinion. Is that, do you think that I mean, from your experience, are you using a single Docker registry, or do you think that it's worth to have several Docker registries depending on the environment, if it's a productive one or not productive one?
Yeah, what I found is very useful is to have at least two. You want one per production, where you only have the images that are actually going to make it to production. What we do a lot internally is the way we have CI/CD set up. Pretty much every commit ends up with a container.
Mm-hmm.
You merge PR, you PR. Okay, something what we do for PRs is when you build a PR, that will spin up an environment. You can go and test. At least there'll be an image you can download and run. But all of those will never make it to production. They're more like PRs, branches for testing, for experimentation. So what we do is we keep the kind of like the global throw anything you want at registry.
Yeah.
But then once we push to production, we do use a different registry because we want that to be smaller, to be more nimble, to know like this is what's been like blessed for production, kind of. And then when you want to roll back, like we use Bamboo, of course. So we use that for tracking releases, but you can use the container registry to do. The one thing that it matters that's kind of important to keep track of is do have a consistent schema versioning. So you know that container 1.1.3, whatever your name is the same across. We use namespaces for this, so every team gets a namespace like registry.com/team A/whatever you want, and then team B. But do keep like I think it's very important to keep consistency in the naming. And then if you have a couple of registries, I find it useful. But other teams have just a single container to throw everything at registry. But I do find it better that way. So it's easier to maintain because you only care about the production one. The other one, if it gets too large, you can like purge images every now and then. You can like kill it and relaunch it. You may even be running it on a less robust infrastructure because you don't care as much. I do feel like it's easier for production. It does add the extra overhead of running two registries. But I found that's not like that big of a deal, at least in my experience.
Thank you.
What about secrets in I2Kit? Do you support them or Docker secrets?
So at this moment, there is no direct solution for secrets. Basically, so secrets, they need to be stored in a common store. And the I2Kit tool is just meant for a single user. So we are thinking now, and this is one of the reasons we are here, we are collecting feedback about how to take it to the next level and make I2Kit a nice tool to work in a team. in a company with 100 developers, for example. And for that, the first proposal that we have in mind is to have a common store that can be run, for example, in Amazon, we can use different services like Dynamo or different services to store key value pairs. And at time of deployment, we can get these values and inject them as environment variables in the different containers. And that is more or less what we have in mind at this moment. But in I2Git as an open source project, is not ready yet.
So yeah, I have a question about weighing up whether it's a better choice to go with Kubernetes or whether it's a better choice to go with either containers or something like I2Git, which you guys are pushing. So obviously there's something that we're looking at as well. We certainly haven't got there yet, but we're weighing it up. What would you say are sort of the main characteristics which would sort of guide you more directly towards a Kubernetes setup, or towards maybe a more containerized approach, or a VM approach? Like, what are the sort of big sort of characteristics?
Yeah, so one of the key ones for me is Kubernetes works very well if you have like a very small, like if you're going through like the microservices approach and having like very small, single-use, kind of mostly stateless microservices. That is where I think Kubernetes works a lot better. Because it's easier to have a smaller one. You pack them on different pods. You don't have to worry too much about them. Just kill them and move forward. But what I've seen that happens a lot is that you're probably going to have more of a hybrid approach where you have some bigger services running and then the smaller, newer ones. And what I found more than anything is that it is hard to run services in Kubernetes. The abstraction layers make it a little bit harder, and also you have to train your developers on all these new concerns about like discovery. It's very easy to, when you're coding, oh yeah, local host, everything's going to be a local host. But then when you're thinking about like a highly distributed environment, you have to think of like service discovery, availability, using something like Hystrix, like to prevent like services from DDoSing all the other ones. So if your team is not comfortable with those kind of like issues and patterns, I think it is better to kind of start slow and first go through the VM, keep your VMs, go to your containers as a first phase. And then as you move forward, go through Kubernetes. Also, for me, the other tipping point is when you start to care more about highly optimized infrastructure, like if running VMs and you're saying, I have all these VMs that are typically at 50% capacity. If that becomes more of an issue, whether it's money or performance or simply like efficiency, that is also a point where thinking about Kubernetes makes a lot more sense. But with the understanding that there is this cognitive overhead of building and operating applications there.
Yeah, so yeah, just to add more details on that, I think that Kubernetes is a nice fit when you have a huge infrastructure, and it's really a good tool to optimize your resources. If you are running thousands, 10,000s of machines, probably you will save a lot of money. But if you are not running at that scale, I don't think there is a strong reason to move to Kubernetes. And in my opinion is that sometimes people is using Kubernetes because from the developer point of view, it's very easy to deploy an application. It's just a manifest. But the operational cost of keeping a Kubernetes cluster is a huge issue, and it should be considered when taking this decision.
Sorry, man. Out of curiosity, I would like to know why you speak so much about Kubernetes and not about Swarm.
Well,
right?
No, this is official. I can talk about this. So Docker is working a lot on integrating Kubernetes with Docker. It should be released like 1 month ago, but it's taking some more time. But the next release is gonna be Docker with Kubernetes, and it's gonna be integrated in Docker for Mac, Docker for Windows, and Docker. So finally, Docker is moving to Kubernetes as an orchestrator, and Swarm is gonna be maintained for a while. I'm not sure about what is gonna happen.
How long?
I'm not sure, because I know that in the company there are a lot of people that think that Swarm is better is easier to use than Kubernetes, and they want to push forward for Swarm. But on the other hand, Kubernetes is like super fancy now. Everyone wants to run Kubernetes, and that's why they are working a lot. Is the highest priority right now is to integrate with Kubernetes, and other features are on
I
maintenance.
guess the most important thing is that all the cloud providers are moving to Kubernetes too, so not to Swarm. So it makes sense that Kubernetes won.
Yeah. And at the end, because if you are running in the cloud, I think that, as we said here, there are a lot of features that you can take advantage to deploy your application in the public cloud.
Yep.
If you are running in the private cloud, then I think that Kubernetes has a lot of value, because it's giving you proxy, networking, load balancer, replica sets. So there, I think there is a lot of value in Kubernetes because you don't have these features available. If you are running OpenStack, you don't have load balancers, you don't have DNS, you have to run those services by yourself. But Kubernetes is nice there, and I think that at the end, cloud providers they are moving to Kubernetes because the money is in the private data center, and there is a huge request to integrate with Kubernetes.
Makes sense.
And on that topic, maybe anyone can tell me. I don't know, but I'm just sort of wondering: is Amazon moving towards providing Kubernetes as a managed service?
Yes.
Yeah, they have.
Oh, this okay.
Yeah, they announced it last year, and
Okay.
but it's in review now.
So they announced it in the last keynote, but they also, so basically they say, okay, this is AKS, Kubernetes as a service, but we are also offering Amazon Fargate, and they say, we think this is the future, but we also have AKS in case you want it.
That was interesting. Like, yeah, we're introducing Kubernetes. It's not yet there, but try Fargate.
It's like a friction bait, right?
Yeah, it's like, don't go away from Amazon.
That is what I think it makes sense for them, because at the end, Kubernetes is kind of it's the second wave of commoditization, where you had VMs and then everybody provides VMs. It's very easy to switch. So now we have Kubernetes. So that's all they offer. If I'm on Amazon today and tomorrow I get a nice offer from Azure to maybe save on costs, you can just move. Fargate, I think, is a very interesting strategy of offering containers as a service. I don't know. It's probably Kubernetes in the back, but what they're offering is just give me your container, we'll run it, we'll give you very nice integration with all the other Amazon features, with security, with load balancers, with permissions. I think it's smart of them, but Fargate might be one of those things where Amazon's really trying to keep you in the fold. Same thing with Lambdas, where it's tricky. I don't know if I would bet on that. I think they're going to be putting a little more effort in Fargate than Kubernetes service. I mean, it feels like kind of the same thing they do with Elasticsearch as a service and Elasticache, where they offer something very basic kind of to keep you there. It's great when you start. As you scale, it's not as good, and probably Fargate will be the star. It kind of makes sense for them. And I'm still waiting to see what the other providers are doing. But I mean, Google Compute offers a very robust managed Kubernetes, and Azure is slowly getting that as well. So it's going to be interesting to see who tries to collect the next generation container applications.
I have another one, probably straying from the topic a little bit, but you mentioned Lambdas. So let's say maybe sort of 18 months, 2 years ago, Lambdas were really super cool and hot. I don't really feel we hear about it too much more. What's your feeling about that? Do you think that they're sort of dying out, or is it one of these sort of, I don't know, what's your feeling about sort of direction of Lambdas?
I don't know. I think the opposite. I think, and this is I live in San Francisco, so it's sometimes you get a little different bubble. There's a lot of startups that are slowly adapting Lambdas, and they're fast. Now Azure has its own function service, and Google Compute has one as well, where they are starting to seeing a lot of, especially cost benefits of kind of starting there. Because when you don't have to pay for servers, especially at the beginning when you don't have that many users, it allows you to scale very quickly, very fast. I think that, I don't know, I feel like in the future, and this is me making things up, I think as containers and VMs can start merging and they get faster to deploy, I think it's going to be a very interesting approach where you have containers that are exposing functions, kind of become almost the same thing. I do believe that, we will get to a point where as a developer, you will only care about hey, I have this code that it needs compute, run somewhere. And I do feel like functions are that. The problem is, and then there's a big Docker project, right? Like for
Yeah,
function as a service on Docker, mostly for on-premise. But I do feel like there's something there. I feel like they started something really cool. Like, oh yeah, you have this code and it's great. And then people started like to use it, and then you start hitting into like, wait, but what's my local dev story? Wait, what's my stage prod story? What's my performance? So now people took kind of a bit of a time, but now as those things are getting more mature, like Amazon is pushing Lambdas very hard, especially on the Alexa service, on their voice applications. Like they have Lambdas as like first class citizen. Whether voice applications make it to the big leagues, we'll know, but there is a push there for that kind of, for like very peaky like applications you're not going to be using all the time. I feel there's a future there.
Yeah. The way I think about that is that the container, the main feature about containers is portability. So once you have the portability, you don't care about where is running the container. And next step is to be cost effective. And for me, and this is related to the talk. For me, the way to do it cost effective is to one option is Kubernetes, and the other option is serverless. And I see serverless as Kubernetes as a service. I want to run this container, it runs, and I don't care. And I don't care about the cluster, it just runs. So that's the way I think about serverless. And my personal point of view is that it's going to be the winner against Kubernetes.
Okay, interesting.
But that's my personal opinion.
Yeah, who knows? We'll see in a couple of years. Well, you're gonna have any more questions?
There were some questions before the talk.
Yes, we like from the team we have a question since we use Docker we use Mac OS, and we run into issues with synchronizing file changes, and we've been using Docker Sync, and some people now try out Docker Machine, but it kind of feels weird that we always need to have a tool on top of it.
Yeah, I got that question several times. And I'm sorry, but I don't have the answer because I know this is a problem, and I know that people in Docker is aware of this. They were working on that, but as I said before, right now the priority is to integrate Kubernetes. So I don't think it's going to be fixed in the next few months. I think there are some tutorials online about how to improve it. But if you want, you can give me more details, and I can talk to the Docker guys, and maybe they have a nice trick for it. I don't know. But I haven't fixed it in my laptop, so I don't know. I don't know the answer.
Okay, awesome. Also, to that question, do you know whether it's like is it an issue that comes from Apple's side, or is it more like from Docker's side?
I think it's
have an
Apple.
opinion
No, I think it's an Apple issue, but they are working on a trick to overcome this issue. So, but the problem is that right now it's like kind of frozen because people is focusing on the Kubernetes integration. So I cannot tell you that it's going to be fixed in a few months or something like that.
Okay, thanks.
But if you give me more details, I can talk to the people from Docker for Mac, and maybe they have a quick fix for the issue.
Yep. Okay.
Look, time for pizza and beer.
All right. Well, thank you.
Thank you, guys.